Hello everyone. Today we will learn about the chapter Nuclear Power Plant. In this chapter we will go through the introductions, nuclear reactions, nuclear fission process, nuclear chain reaction, constituents of nuclear power plants, nuclear reactors which are main part only, types of power reactor commonly used, and final nuclear energy tale in India. First of all, we will know the importance of nuclear energy, how much electricity is generated by various fuels. We can see that coal constitutes major parts, it constitutes 39% of total electricity production, whereas gas constitutes 19% and oil constitutes 7%. It means that total electricity generated by the fossil fuel is around 65%. Here we can see that hydro also play major roles. 16% of electricity is generated by hydropower plant, and finally nuclear power plant, we can see that 17% of electricity is generated by nuclear, and these are the 2%, remaining 2% are for other. This would like maybe solar energy, tidal energy, maybe whatever. We will now see that what are the different nuclear power plant in India, where it is located, what is the output and its type. The first nuclear power plant in India was in Tarapur, Maharashtra. Its type was BWR, boiling water reactor, and its output was 160 megawatt. Second, Rawat in Rajasthan. It started in 1964, was type of pressurized water reactor, and output was 100 megawatt. Another nuclear power plant is located in Kalpakkam, Tamil Nadu. This one started in 1970. It is again a pressurized water reactor, and its output is 220 megawatt. And we can see that in Aurora also in Uttar Pradesh. It started in 1976. Its type was pressurized water reactor, and output megawatt. Its output is 220 megawatt. Now we will discuss what is nuclear reaction. As we can, we have told that the nuclear energy, the energy is released by the process of nuclear reactions. And what principle it is based on? Everybody has heard the Einstein equation, E is equal to mc square. In nuclear reaction, there is two types. One is nuclear fusion and second is nuclear fission. Fusion means the term indicate fuse one or two nucleus combine together to form a heavy nucleus, thereby releasing high energy. Whereas in fission, A heavy nucleus is split into two or three or more smaller nucleus. Fusion process take place in the sun, where two hydrogen nucleus combine to form the helium, thereby releasing a tremendous amount of energy in the sun. Whereas in power plant, the electricity is generated by the nuclear fission process. As we can see that this data, one fission of uranium 235 causes the 230 megawatt of energy. It's very huge. Now we will discuss the nuclear chain reaction. Here we can see that one neutron is bombarded with the uranium 235, thereby releasing barium and krypton and 3 neutrons. You can see that in reactant part we can see that there is only one nucleus, whereas in products part, resultant part, we can see that here is 3 neutrons. Chain reaction is defined as fission reaction where neutron from the previous reaction continue to propagate and repeat the reaction. It means that these 3 neutrons will again react with another uranium 235 and it will repeat the reaction. Here we can see that the brief diagram of chain reaction, how it works. Here we one nucleus is bombarded with uranium 235, thereby releasing 3. In previous slide I told the chain reaction that one nucleus in reactant part and there is 3 nucleus in product part. Here we can see that there 1, 2, 3 nucleus. This again single nucleus is bombarded with uranium 235, thereby also releasing the 3 nucleus. Similarly, in second also 3 nucleus and third one also 3. You can see that here it was previously it was 1 nucleus, then were 3 nucleus, then 9 nucleus. It means that number of nucleus goes on increasing till further nuclear reaction. That's why we have to control these nucleus production. Now we will discuss the constituent of nuclear power plant and its law. This is the schematic diagram of nuclear power plant. Here we can see that this outermost lining is containment building, which is also called as biological shielding. The nuclear reactor vessel is kept inside the containment building or biological shielding. Here we can see that the control rod is placed vertically in the reactor vessels. And this black vertical line indicates the fuel element. It is generally solid and cylindrical in shape. Generally we use uranium 235. Here we can see that is pressurizing system. The fuel heat is generated and transferred to the heat exchanger and thereby exchanging the heat again returns to the reactor vessel. Thereby a cycle goes normally as in any power plant. Okay, I will discuss this nuclear reactor power main plant in next session. Till now I'm closing this session. Thank you very much for watching.